In the name of God, hello dear students of grade 11. Welcome to Thinkable Physics. This is my YouTube channel. My name is Masoud. My profession is physics. And I'm at your service to explain physics curriculum. So far we talked about one section from chapter 7. And the title of chapter 7 is the electrical energy and current. But in this section, the second section of this chapter, we are going to explain the capacitors in general and the role of capacitor in our daily life. More or less, you are familiar with capacitors. Knowingly or unknowingly, you use capacitors. Whenever you actually take a photo by a camera, the flash of camera is provided by a kind of capacitor within the camera. And it's not just for camera. You can whenever you take a photo by cell phone, the flash is produced by capacitors within the cell phone. When you open the back of any electronic device, like satellite, like radio, like TVs, actually you find a lot of capacitors on the motherboard of these devices, actually even your body, even the cells of your body are considered capacitors in some ways. Actually, even the gasoline tank of the car, gasoline tank of the vehicles are considered capacitors in some ways. Even clouds are considered capacitors. Our planet Earth is considered capacitors. So the application of capacitor in our daily life is very wide. We have a widespread application in our daily life. Believe me, I cannot count the usage of capacitor in our daily life, because it occupies all areas of our life, right? In this lesson, we are concentrating on the capacitors and the role of capacitors. In this lesson, we are going to know about the function of capacitor. What does the capacitor do? Why is it important? What's the function of it? Why do we use capacitors? As I told you, if you think about it, so right now something comes to my mind. For example, if you take a look at this ceiling fan, this ceiling fan contains capacitors. If capacitors don't work, the ceiling fan does not work. So ceiling fan, coolers involves capacitors. And I told you there are a lot of capacitors are in charge of several actions, several functions in our daily life. I'm gonna start by this introduction. I'm gonna start our lesson. Let's get started. Firstly, this title is the capacitors and charge storage. I'm gonna define. I included the definition of capacitance and capacitor separately. What's the capacitance? Is the ability of a conductor to store energy in the form of electrically charged particle. So the main function is what? The main function for the capacitors is storing energy. Storing energy in the form of what? In the form of charges, right? Definition of capacitor. As clear from its name, capacitor means a machine, it's a device. It's a device to store electrical potential energy. It's a machine to store electrical potential energy. I've prepared the graph for you. This graph talks about the types of capacitors. Let me show it to you. And I told you we cannot categorize actually capacitor in a graph. You cannot say there are 3 types of capacitor or 4 types or 5 types. Based on the shape of the capacitor, this device is classified. So we name the type of the capacitor by its shape actually. For example, if you have a spherical capacitor, you name it as a spherical. If you have a, for example, cylindrical capacitor, you name it as cylindrical capacitor. So but here actually I only mentioned 3 categories of capacitor, 3 groups of capacitors, which are parallel plate capacitor, spherical capacitor, and electrolytic capacitor. But our concentration actually in this lesson is on parallel plate capacitor. Parallel plate capacitor is divided into 2 parts, into vacuum capacitor, into dielectric capacitor. Vacuum capacitor, dielectric capacitor. Maybe you are not familiar with dielectric. Don't be confused. Dielectric means insulator, like paper, like air, like glass. So dielectric means insulator, right? Let's read the applications of capacitors. Application. What's the application? I told you in the introduction of this lesson, and I told you we cannot actually restrict the role of capacitor in 1 or 2 or 3 regions in our daily life. So capacitor enters actually several actually areas of our daily life. But your book mentions actually 4 actually applications. I'm gonna read it for you. The first one, tuning the frequency of radio receivers. For example, I give you this radio and I want you to actually look for a certain frequency, any frequency. So whenever you hit the button, or whenever you actually turn the button to search frequency, so unconsciously you change the capacitance of the battery. So tuning frequency, adjusting frequency is taking place by changing the capacitance. So inside this radio, it's an electronic device. Inside this radio, there's a motherboard, and above the motherboard, there are a lot of actually capacitors. Right. That's the first application. The second one, eliminating sparking in automobile ignition system. There's a device in ignition system of the car. This device is called a sparking plug. A sparking plug is in charge of what? A sparking plug is in charge of providing sparks in ignition system of the car, right? So the actually capacitor in the ignition system of the car eliminates or removes these sparks. The sparks provided by the sparking plug actually are removed by the capacitor. The third one is storing energy in electronic flash units, in camera, cell phone, and etc. So whenever you take a photo by a camera, whenever you hit the button, actually this camera is an old camera, old type of camera, but it's just I've brought it for actually better understanding. It's not just for camera actually, taking a photo, providing flash in any device, in camera, in cell phone, in fluorescent lamp. So providing flash, actually this action actually is taking place by the capacitors, right? And the last one, the fourth one, typing text by keyboard in computer, calculator, etc. So for example, whenever you hit the button of a computer to type any letter, anything, so you you change the capacitance of the computer or of the device. By the way, this is the capacitor used under the button of the computer keyboard. The type is parallel plate capacitor. But the electrolytic capacitor used in the motherboards of the electronic devices, this type is called electrolytic. You see, electrolytic. This one actually ceramic capacitor, electrolytic capacitor, and parallel plate capacitors. Right. So, for example, this is the motherboard of an electronic device. This is capacitor. You see this one. This is electrolytic capacitor. This is the big size of electrolytic capacitor. We have a smaller size. There are a smaller size of electrolytic capacitors. These blue ones are ceramic capacitors. And actually, there are a lot of capacitors on the motherboard of the electronic devices. Right. Let's move on to another subject, another title. The title is Definition of Parallel Plate Capacitor. So, as I told you, we focus on parallel plate capacitor. What's the definition of parallel plate capacitor? Let me read it and I'll break it down for you. It says, parallel plate capacitor consists of two parallel metals. It consists of two parallel metal plates. So parallel means two parallel conductors. Separated by a small distance. Two parallel conductors. Even, for example, this is a capacitor. This capacitor is used in coolers. So we use this type of capacitor in the coolers. And it's not parallel plate capacitor, actually. This is actually cylindrical capacitor. We name it as cylindrical. But the basis of all types of capacitor is parallel plate. So existing parallel plate is actually essential. Existing parallel plates in any type of capacitors necessary, right? For example, this spherical or this cylindrical capacitor consists of two parallel plates. These parallel plates are made of metals, right? They are made of metals. This is a parallel. Let me show you actually, I want you to guess the name of this device. We used it in fluorescent lamps, especially gaseous fluorescent lamps. And it consists of, and actually this machine, this is called glow starter. Glow starter of fluorescent lamp, especially the gaseous fluorescent lamp, is not, the machine itself is not considered capacitor, but it involves capacitor. Let me open it for you. Whenever you open it, actually this part is a capacitor, this part. And it consists of two parallel plates. You see? So in any type of capacitor, you find two parallel plates. Sometimes parallel plates actually and these parallel plates are conductors. They are made of metals, they are conductors. And in some type of the parallel plate capacitor, within the parallel plates, we have an insulator, we have a dielectric, right? So I can say in some type of them, dielectric is sandwiched between two conductors. Dielectric or insulator is sandwiched between two metal actually plates. But in some other parts, some other types of capacitor of parallel plate, there is no insulator, we name it as vacuum. So there's a space, empty space between two parallel plates, right? So this is the definition of parallel plate capacitor. And the best example for parallel plate capacitor is the keyboard of keyboard buttons, actually, right? Keyboard buttons of computer, of calculator. They are good examples of what? They are good examples of parallel plate capacitors. Charging capacitor. I'm gonna leave this subject for the next lecture. Thank you very much for watching this video, and bye-bye.